All right, in this podcast, we're going to talk about limiting reactants. All right, so a limiting reactant is basically the reactant that is consumed first, or you use all of it, you run out of it. It limits the amount of products that you can form. In order to determine limiting reactants, or reagents as they're sometimes called, you basically have to do two stoichiometry problems to figure out how much product each reactant would make on its own. And then whatever the smallest answer is, that is the total amount you can make, and whatever led you to that answer is the limiting reactant. All right, now the excess reagent or reactant is the one that you don't run out of. It's the one you have extra of in the end. So like down here, you see we have car bodies and cars. We made 8 cars, and we have 16 excess tires. Okay, the total amount that you end up making is what we call yield. All right, if you're a steps person, here are some steps for you on what you need to do in order to find the limiting reactant. But essentially, do 2 stoichiometry problems, pick the smallest answer, that's the total amount you can make, and whatever reactant led you to that answer is the limiting reactant, and the other one is the excess. Okay, so here's an example problem. First off, make sure your equation is balanced. If it's not balanced, you definitely need to make it balanced. Okay, now ours is balanced. Wants to know the mass of ammonia, so we're trying to figure out the mass of this. That can be produced from a mixture of 500 grams of N2 and 100 grams of H2. All right, so what you want to do is you want to do 2 stoichiometry problems. Cool, so I'm going to start with my 500 grams of my N2 over 1. This is a gram-gram problem. So I've got to convert it to moles. And then I'm going to do my mole ratio. My ratio is 1 mole N2 to 2 moles of ammonia, NH3. And then I'm going to go to mass of ammonia. And the molar mass of ammonia is 17.034 grams. All right, then we solve for that problem. All right, so a little bit of math, and we get 608 grams. All right, now we're going to repeat the process, but this time we're going to start with our H2. So I got 100 grams of H2 over 1. All right, and I'm taking it to the moles, so I need the molar mass of H2, and then the ratio. We got 3 moles H2 for every 2 mole NH3, and then 2 grams of ammonia. So hopefully you notice that the very tail end of these are the exact same. All right, so I got 563 for this one. Okay, so that means that this is the total amount we can make because it's the smaller of the 2 answers. And whatever led me to that, so my 100 grams of H2. So H2 is my limiting reactant. And N2 is my excess reactant. All right, now please notice that on these, so please notice that this last part right here, it should always be the same in every limiting reactant problem because you need to be converting to the same substance in order to compare the numbers. All right, one more example. Hey, this time I was nice and I actually balanced the equation. So we've got 2 grams of ammonia mixed with 4 grams of oxygen. Need to know the limiting reactant and the total amount of nitrogen monoxide. So I'm looking for this in grams. All right, so I'm going to start with my 2 grams over 1. All right, and then I want the molar mass of ammonia down there. All right, now my mole ratio. So I got 4 moles of ammonia for 4 moles of nitrogen monoxide. And then back to grams, but this time we're doing NO, whose molar mass is 30.01. All right, now multiply that all up. All right, and we get 3.52 grams for this one. All right, now we're going to repeat, but we're going to start with oxygen, 4 grams of oxygen. And so I'm going to take it to the mole. So molar mass of oxygen on bottom. And then my mole ratio. So my oxygen, and again, I want to convert them to the same substance. So converting them both to NO, nitrogen monoxide. So that last part should always be the same. And you get 3.0. All right, so that's the total amount I can make. What led me to that, which was my 4 grams of oxygen, is my limiting reactant. And my excess is the other one.